So now we come to the main mathematical formalization of games that have dynamic or temporal structure, which is extensive form. So normal form and extensive form together are the kind of two main classes of formal games that are studied in game theory. Although there are many other kind of ad hoc extensions that sometimes come up, but normal form and extensive form are the two big ones. So now I have to hit you with a few slides of kind of big definitions. So an extensive form game is going to be a tree together with a bunch of labels carrying extra information. So technically this is a thing called an extensive form game of perfect information, but you can ignore that last part until next week when we'll talk about extensive form games without perfect information. So we have some number of players, which is fixed. We're going to say, so a tree consists of internal nodes, so what I'll call nodes, which are internal nodes, and then leaves. So the picture you should have in your head is something like this. So the nodes are this, this, and this, and then the leaves are these four. So each node is going to be labeled by one of the players, and that player is going to own that node, which means that when the game is in the state represented by that node, then the owning player is going to be the one that chooses what happens. And then each leaf is going to be labeled by a payoff vector, that is to say a payoff for every player. And then we're going to say a play of this game is going to be a path from the root node to a leaf node. So we're always going to start at the root, which is the initial state of the game, and then we're going to go down the tree as the play evolves until we reach a leaf, at which point the play ends. Okay. It is useful to have another bit of labeling, which is to say we have a set of actions, and we're going to label every edge of the tree with an action. Now this week we could get away without actions, but we're going to need them next week, and also actions are kind of useful for intuition. So I'm going to introduce them now. So this comes with the labeling by actions comes with a requirement, which is if we have two different edges which are coming out of the same node, then these have to have different labels. So or to say the contrapositive of this, we cannot have two different edges with the same parent node and the same label. So what this means is that if we have a pair consisting of a node and a valid action, where valid means the action labels some outgoing edge of that node, then it labels a unique outgoing edge of that node. So that means that we always know where to go. We can never be in the situation where we say an action and we don't know where to go. Okay, and so yes, as I say here, for now, this technically makes no difference because we could always take the actions to be the same thing as nodes. But it's kind of useful to have a separate labeling by actions. Okay, so here's an example. So the ultimatum game is a game where player one moves first. So here in the root node, the root node is owned by player one. So player one moves first. And the game is that player one has to split a tenor. And the player one has two choices. They can either make a fair offer, which is 5 for each, or they can make an unfair offer, which is 8 for themselves and 2 for the other. And then, so player one chooses fair or unfair. And now, in both cases, player two gets to make a choice. Namely, they can choose to either accept the offer or reject it. This U should be an A. And if player 2 accepts it, then the players both get the payoffs defined by player 1 split, and if player 2 rejects it, then both players get nothing. So this is called the ultimatum game. So player 1 makes an ultimatum and player 2 can call their bluff. Okay. Now, strategies for extensive form games are a little bit more complicated than for anything we've seen previously for strategies. So a pure strategy for a player in an extensive form game is going to be a choice of action at every node that player owns. So what that means is that at any point in the game at which that player could be called on to make a choice, the strategy has to tell them which choice to make. So we have a restriction that the action has to be a kind of valid action, which means it has to be the label of some outgoing edge of that node. And there's a kind of important subtlety here, which is that we really insist that the strategy has to say a choice at every node a player owns, even if the same strategy says that that node is unreachable. So we could say that we could have a node up here owned by the player, which says always go this way, which means that as long as we're following this strategy, we're never going to end up in the subtree down here. But we're still going to insist that the strategy says what we would do at nodes that the same player owns in this subtree. The reason we do this is that reasoning about optimality is all about thinking of the form, what if we made a different choice? So why was it a good choice at the beginning to go this way? Well, because if we had hypothetically gone the other way, then we would be in a worse situation. And what that means is that we have to know what we would do if we were here anyway. Okay, and then a pure strategy profile is going to be the same thing that it always is, which is a tuple consisting of a choice of strategy profile for every player. And what this means is that this is the same thing as a choice of action for every single node in the tree, because every node in the tree is owned by some player. Okay, so if we have a picture of an extensive form game, we can kind of annotate it to visualize what strategies are. So here I've highlighted three actions here, and these. So if you highlight the one outgoing edge from every node, then that defines a strategy profile. So here, this is the strategy profile where player 1 strategy is to make a fair offer, and player 2 strategy is to accept if it's a fair offer and reject if it's an unfair offer. And so with this kind of picture, we can very easily read off the strategic play, which is the play that happens from the players following the strategy profile. Namely, we always follow the highlighted action. So we start here, we follow the highlighted action, and we end up here.